So this is the condition. So we find another condition for always. In this one we should trigger A or B, and always block running, but here the positive age. So when the clock reaches the positive age, the always block running again and again concurrently. And here the another syntax of this one, conditional statement. Like a high level programming language, you can use the else if and the case statement. It's like this one, you write if, and this is the condition of the if, and you use the begin and end for your statement. Okay, so if the total, for example, is less than 16, this block running. And for example, you can use the else if. So if the sum is less than 75, begin and everything between begin and end running again and again. And also you can use the else. The syntax is clear here. And also for the case, if you remember something like a switch case, sorry, we have something about like a switch case. We write the case keyword, and in the parentheses you write your variable. Okay, in here it's something different. For example, here there are different kind of things that can be set to the opcode. Okay, for example, if this one set to the opcode, for example, if the opcode is the binary 10, actually to quotation B, it means that is a binary. Okay, so opcode, if the opcode is 10, A plus B assigned to the Z. If the opcode is 11, A minus B assigned to the Z. If the opcode is the 1, A times B assigned to the Z, and so on. And also if this default, it means that if this condition is not correct, 2 assigned to the Z. Okay, and you should write the end case to finish the case. And also in the Verilog you have a loop. You can use the for loop, while loop, repeat, and forever. For, while, and forever is like a high level language. It's just repeat is a bit different for you. If you have some example here, for example, for the for, you should write this syntax, I from 0 to 10, and well, increase with one number, and you should write the begin and end, and this is your statement. So for 10 times it happened. And for example, for the while, you have one condition, and again between begin and end. So this is the open and close clock, and here the statement. And also you have something different, repeat. It means that 5, for example, you can write the repeat as a 10. It means that this statement running 10 times or 5 times or 6 times. So it's very simple and very funny things. Then just repeat and the number of the repetition, and between begin and end you write your statement. And this is some different example of a case statement. Okay, you can see that if the A is the 0, for example, we assign C to B. If the A is a 1, we assign 2 to B. If the A is 1, 0, we assign E to B, and so on. And don't forget finish it with the end case, and don't forget semicolon here and also in this part. Here we have some example. Actually this example will be the same as your experiment, your lab sheet, but I'm going to explain it 2 times because it will be useful for you. For the flip-flop, for example, this is the flip-flop. You have some input, you have some output, you have a clock, you have reset, something like this. We are going to write this flip-flop with the Verilog language, and because of always we can find that is the behavioral type. Okay, so we write the module, the name of the module, and also this is the input, our output. You can see Q, data, underline in, clock, and reset. And also here we define our input and output. We can define it inside, but here is better because it's more clear. And your input is the 1, 2, and 3, and your output is Q. And also we know that this is this output, we need this output as a register, so we write it as a register here as well. And here we write our always block. This is our initial block, and this is our always block. In our always block we need the one condition, so we write it positive age clock. It means that when the clock reaches to the positive, let me write